Now these gear pumps. I'm at Williams Shipping today. Tested the pump and we found that it's faulty. What's happened is been over pressurized, and I'll explain to you how I know that. I've done a test on the pump, and from the test I've established that there is something wrong, and I've stripped it apart, and I'll show you how I can tell that this pump has been damaged through the overpressurization. So when I strip this pump, I've taken the gears out, you will find that the pump will only wear on one side, and it will wear on the suction side. Now, I don't know whether you can see that. There we are. I'll just pull that over, and you can see that wear mark down there where the gears have actually cut into the aluminium housing. You look the other side, on the pressure side, and there's not a mark. It's as good as the day that that pump was made. And the reason for that is that because this is the pressure side, this side is the pressure side, that forces the gears across, is pushing the gears across and embeds them onto the suction side of the pump. So whenever you look at a gear pump, you always look at that on the suction side for the wear. So what I've done, I've loosely assembled this pump on the workbench, and you can see this is the driver, this is a tapered shaft that's connected to the electric motor, and this is the driven. Now, with the large port here, this is the suction, and coming around the other side, that's the pressure. See that the oil is sucked in through these gears here, comes around the outside of the gear, and that will work either side, outside of the gear, and then out through the pressure port at the side. Now, the cheek plates that go on the ends of the gear, on the ends of the gear, and you have these both sides, this keeps the oil within the gear. You can see that again you have, and I just tilt that slightly, wearing on this side. Digs in and removes material from that side. Of course, once you remove the material, the pump loses flow and basically of no further use. These on the back are the seals that basically seal the pressure into the housing between the gears. Because what we don't want to do, we don't want oil escaping away from the gears and away from the pressure port into the case. That's the suction port connectors on. Now we move to the other side and put the pressure connectors on. So what I've done now is I've lifted this double pump up into the engine. It's got flexible coupling, and just going to do the 4 bolts holding that onto the housing, connect up the pipes, and then we should be able to give it a run.
So we've checked the speed with the tacho. We've got 2000 RPM. The pump is 44 cc's per rev. So a quick calculation, 44 times 2000 divided by 1000, that gives us around 90 litres per minute. So that's looking good. We check the other side and we're done.